Good morning, students. Now, the next topic, the application of Gauss law is the electric field due to infinite plane sheet of uniform charge. So, this is the infinite plane sheet. This complete here. This shows that infinitely it is extended. Now, how will we take? Next step is to choose Gaussian surface. Now, you can choose cuboidal or cylindrical Gaussian surface here, but the cylindrical Gaussian surface has to be in such a way that the cylinder bisects this sheet. So that means if you have a sheet, okay, like if you have this sheet, suppose this is the sheet, then at the center midpoint of the sheet, the cylinder should be perpendicular to it, and half of the cylinder should be on the upper side and half of the cylinder should be on the lower side. Then it will be perpendicular bisect. The same way half of the cylinder, so this distance is r, and this dotted line to show that it is on the back. Okay, this distance is also r, so this is perpendicular bisect. Okay, now suppose the sheet has a positive charge. It can be negative. I assumed it to be positive. Only the direction will change, nothing else. So, in the cylinder, I'll take three surfaces, base, another base S1, S2, and third curved surface. For S1, this is the direction of the area. And electric field radially outward for the sheet. So, they both are in same direction. Theta will be 0 degree. For this curved surface, area will be perpendicular to the surface, and electric field is out. Due to the sheet, it is outward. So the angle between them is 90 degrees. So when you take E dot ds, then cos theta here will become cos 90, which is 0. So flux because of this part, because of the curved part, will be 0. Now coming to this place, this is the area vector, and here electric field is in this direction. So again, angle between them, here this is the area S direction of S2, and the electric field is in this direction. So they both are parallel to each other. So again, theta will be 0, and cos 0 is 1. Here also theta was 0. Here also theta is 0. Okay, so now let's apply Gauss law. So it is E dot ds is equal to q by epsilon naught. So it will be dq. Suppose the small charge on this is dq, and this area is ds. dq by this will be dq by epsilon naught. And because it is uniformly charged sheet, so here sigma will be equal to dq by ds. Okay, so dq can be written as sigma ds. Is equal to sigma ds. So I'll replace this dq by sigma ds upon epsilon naught. Okay, now you see E dot ds. So I'll write three parts. E dot ds for S1 plus E dot. Now I am not writing circle. Circle is for the closed loop. Now I have broke the area into three parts for S2 plus E dot ds for S3 is equal to sigma ds by epsilon naught. Okay. Now for S1, for the first surface, E and ds area, they both are in same direction. So E ds cos 0 is 1 for S1, plus for S2 again they are in same direction. So E ds S2, plus this is for the curved surface. You know these two are perpendicular, so there will be 0. Sigma ds by epsilon naught. Here you have to mention, when you are writing here, you have to mention here that E is perpendicular to ds. So this will become 0. Okay. Now here, because see, now here in these two terms, electric field's value will be same. Suppose E is the electric field at this point, from this place to the this length r. Same is the distance here, so magnitude will be same, only the direction is different. So E can be taken outside. Every point, see, every point on this surface is at same distance from the sheet. So every point here will have same electric field E. So it becomes ds for S1. Same way for S2 also, E integral ds for S2 is equal to sigma ds by epsilon naught. Now ds is what? Ds is ds only, small area, no? So integral ds we can write ds only. E, this becomes 2E ds is equal to sigma ds by epsilon naught. Epsilon naught. Now ds cancels. This implies electric field is equal to sigma. Okay, electric field is sigma by 2 epsilon naught. This is electric field due to a infinitely charged plane sheet. Okay, and direction will be, if negative charge is there, sigma by 2 epsilon naught radially outward, not radially outward, outwards, away from the sheet. And if it is a negative charge, then sigma by 2 epsilon naught towards the sheet. Okay, this application E directed away from the both sides for thin sheet for a positive charge, but for negative it is towards it. And electric field is independent. If you see here, electric field is independent of R. It does not depend on R. That means electric field is uniform. So no matter, so if you have a plane sheet, due to this electric field will be equally spaced parallel lines. Uniform lines are there. This is the case when electric field is independent of R. In all other cases, electric field was dependent on R, either inversely dependent on R or inversely dependent on R square or directly proportional to R inside the solid conductor, solid sphere. But then here, R is not anywhere in numerator or denominator. Okay. Now, if you have infinite plane sheet of uniform thickness, this was a very thin sheet. But if your sheet has some thickness, so here is your sheet having some thickness, conducting sheet having some thickness. Okay, so infinite plane sheet of uniform thickness, conducting sheet of uniform thickness. So if there is uniform thickness, what will happen? Charge will reside on the surface. So there will be charge on this side and some of the charge will be on this other sheet on the back side. In between this region there is no electric field. Okay, so there will be this kind of setup divides the region into three parts. Okay, one part, second part, third part. Now what will happen? Now here if you have to find electric field in region 1. Electric field in region 1, see, see this is sheet 1. Say suppose A, and this will act as sheet B. Okay, electric field in this region, the electric field due to this first sheet will be away, sigma by 2 epsilon naught, and due to this also it will be away only, so sigma by 2 epsilon naught. So what you get, they both will be added, so E1 will be 2 sigma by 2 epsilon naught, which is sigma by epsilon naught. Okay, this is the expression. Now if we come to this region, electric field because of this is away in this direction, due to this it will be away in this direction. They both will cancel because this is sigma by 2 epsilon naught, this is also sigma by 2 epsilon naught, so they both will cancel and you'll get 0, E is equal to 0. And when you come to this region, here because of this sheet B, electric field is away, and because of this sheet also electric field is away. This is sigma by 2 epsilon naught. This is also sigma by 2 epsilon naught. They both are in the same direction, you have to add. So your electric field here will be 2 sigma by 2 epsilon naught, which is sigma by epsilon naught. Okay, this side direction is different, this side direction is this side, and in between electric field is 0. This is for a thick sheet, not a thin sheet, for a thick sheet. Okay, electric field due to next condition is electric field. We'll do the next condition also. Electric field intensity due to two thin infinite parallel sheets. So two thin infinite parallel sheets. This is not thick sheet. This is two different sheets which are parallel. Thick sheet में what will happen? The charge, because sheet है ना parallel, so charge both sigma will be same. Both the sigma on sheets will be same. So positive, positive, negative, negative. But here we are taking two different sheets. So one can be positive, one can be negative. We can have different charge densities also. So here we will assume also different charge densities. So suppose this is positive plus sigma is the density, charge density. This is another sheet with this is suppose sigma A and this is sigma B. They may both be positive, one positive, that we will take later. Here we have taken different densities. Okay, now again there are three regions, 1, 2 and 3 region. Now in region 1 you come here. Due to this first sheet A, electric field is in this direction, sigma A by 2 epsilon naught. Due to this sheet also electric field is in this region away, and because of this it will be sigma B by 2 epsilon naught. Okay, so in region 1 electric field, they both will be added and you will get sigma A by 2 epsilon naught plus sigma B by 2 epsilon naught. So 1 by 2 epsilon naught will take sigma A plus sigma B will be left out. This is in the free space, that's why we have taken epsilon naught. If in any other medium it will become epsilon. Okay, this is in the region 1. Now come to region 2. In region 2 you see due to this sheet electric field is in this direction away. sigma A by 2 epsilon naught. Due to this sheet, electric field is in this direction, sigma B by 2 epsilon naught. So they both are in opposite direction. So what will happen? In second region, in region 2, we'll have to subtract sigma A by 2 epsilon naught minus sigma B by 2 epsilon naught. So when you'll take 1 by 2 epsilon naught common, you'll get sigma A minus sigma B. Okay, this is the expression in region 2. Now come to region 3. In region 3, because of this sheet, direction of electric field is here, sigma A by 2 epsilon naught. And due to this sheet also, electric field is away, sigma B by 2 epsilon naught. So in region 3, we'll have to add the 3. So sigma A by 2 epsilon naught plus sigma B by 2 epsilon naught, 1 by 2 epsilon naught taken comma, sigma A plus sigma B. Okay, I'll write that 1 by 2 epsilon naught sigma A plus sigma B. These are the three cases when we have taken two different sheets of different charge densities. Now here we will take special cases. Now if sigma A is equal to sigma B, if both the sheets are having same charge density, equal, both positive, both negative and equal also, that then it will become the case of the thick sheet. There also we had same densities. So in that case what happens? Sigma 1, see both are equal, so it will become 2 sigma. Suppose sigma A sigma B equal to sigma. So it will become 2 sigma and that 2 will cancel, so you'll get sigma by epsilon naught. In region 2, that means this region, electric field become sigma minus sigma 0. It will become 0. And in region 3, again you'll get sigma by epsilon naught, but the direction will be different. This is for this case. Now there is another case. If sigma A is equal to minus sigma B, okay, that is sigma A is sigma and sigma B is minus sigma, then what you will do? That means they both are equal charge density but of opposite sign. So you plus sigma and this becomes minus sigma. Then what will happen? Then you see region E1, first region. Here sigma minus sigma, this becomes 0. So electric field in this region will become 0. Then E2, this region, come to this region. This is plus sigma and this becomes minus sigma. So the direction also becomes this side. So you see this expression for region 2, sigma minus of minus sigma will become plus sigma. So you'll get 2 sigma here and you'll get sigma by epsilon naught. Okay, this is in this region. This region electric field is sigma by epsilon naught. And third region, this is third, sigma minus sigma will become 0. Okay, so this is the these are the conditions. So here in this condition only this region will have electric field, or outside there won't be electric field. Okay, when it is sigma, this is minus sigma. This is the case of a parallel plate capacitor. Okay, here you have two sheets, plus sigma minus sigma, and the electric field is confined only between the two plates, and this is uniform electric field. Outside here there is no electric field. But when you have equal charge density of same nature, then this region will have 0 electric field, but here and here you will have electric field. But if you have same charge density but of opposite nature, then outside these two regions will have 0 electric field, only the field is confined in the center region. Okay, that is it.